Let's look at a couple of more of exponential equations type 1, where both sides can be expressed as the same base. Here's a problem over here. 0.75 raised to the x plus 1 power equals 9/16. Well, here this is kind of a trick question. 0.75 is a fraction, and once I convert it to a fraction, then I can see that it's related to 9/16 because 9 is the square of 3 and 16 is the square of 4. So 3/4 to the x plus 1 power, that's the same as that side right above it, is the same as 3/4 squared, because 3 squared is 9 and 4 squared is 16. Now we can pop off the exponents and set them equal. X plus 1 equals 2, so therefore x must be equal to a 1. Here's another kind also involving decimals. 1/1000th, which is 10 to the negative third, raised to the 3x power equals 100 raised to the x minus 9 power. Well, both of these are related to base 10. As I said, 1/1000th is 10 to the negative third. 100 is 10 squared. So now that I have that, I can do the multiplication. Power raised to a power and I will multiply, and a power raised to a power and I will multiply. And by the way, it has to be the whole thing there multiplied. So that negative 3 times 3x is negative 9x. 2 times x is 2x. 2 times negative 9 is negative 18. Well, let's pull the x's over here. So negative 11x equals negative 18. So therefore x is equal to 18/11. Well, what I want to know is if this is really a solution. If it is, then I should be able to plug it back into the original equation and plug 18/11 in for x. So that's what I've done down here. 0.001 raised to the 3 times 18/11 power. So all of this is in the exponent. All of this is in the exponent. Then that should be the same as 100 to the x minus 9 power, where x is 18/11. So I'm going to pick up my calculator and see if those two are true. I don't even need an exact expression for them. I just want to know if those two are the same. So there it is on my calculator. There we are. Okay, so here's the first one. 1/1000th raised to 3 times 18 divided by 11. And that works out to be that expression right there. And then 100 raised to the exponent that I used over there, and it works out to be the same expression. Okay, along those lines, we have another problem like that where both sides can be expressed with the same base. Well, 1.5 is really 3/2. Do you notice that 27 is the cube of 3 and 8 is the cube of 2? Therefore, this is that base raised to the third power. So 3/2 to the x plus 1 is 3/2 to the third. That 3/2 to the third still has a power of x on it. So I do the multiplication over here on this side, that's 3x, and then just pop the exponent off on this other side. So x plus 1 equals 3x. That means that 1 equals 2x, because I subtracted x from both sides, and 1/2 is equal to an x. Okay, now let's do a equality with this problem. Let's see if we can graph this thing and show that 1/2 is equal to an x. So on my calculator, I have the expression in y equals. There it is there. You can't see all of it, but I'll see if I can scroll past and you can find it all. Negative 27 divided by 8, all of that raised to an x power. So let's look at the graph of the thing. The graph of the thing looks like that. Not a very interesting graph. It looks like it has an asymptote off to the left and then it crosses right there. Well, here's a way to see. We decided that 1/2 ought to be the 0 of that thing. So we press the trace button, we type 0.5, press enter, and sure enough, y turns out to be 0. Now we can use this graph to solve an inequality. The inequality is this one, and I want to know where this function is above 0 or more than 0. Well, I know that the 0 is at x equaling 0.5, and I know that the curve looks like that. So let me zoom in on this. Here's a good trick. We can have a little bit better look at this. So I'm going to navigate to the place, I'm going to navigate right on top of the origin. Let's see, trace. And, oops, that's not what I wanted to do either. So what I'm trying to do is just navigate. I'm just going to look at the picture again and start tracing until I'm right about the origin. Then I press the zoom, then I choose zoom in. I don't actually zoom in until I press enter. And there's my picture. Okay, so I can use that picture to answer the question, where is the curve above the x-axis? Well, over to the left, it looks like it becomes really close to the x-axis, so the x-axis is probably an asymptote. That means you can go out there forever. So the interval would be from negative infinity all the way out here, all the way to 0.5, where x is 0.5. So this thing is above 0 from negative infinity to 0.5. And above means not including, or the greater than means not including. Infinity always gets a parenthesis. Now let's do the same thing. Let's ask where this thing is below the x-axis. And let's just change this problem to below or on, just so we can talk about interval notation a little bit. And so here's my curve again. And I want to know where this thing is below or on. Well, it's below, starting right at the 0, and then on down to the right. And I believe it's probably going on down forever. So that would be from the place 0.5 out to infinity. So the place where it starts being on or below the x-axis is at 0.5. It's after that, it's out to infinity. And then, because this includes an inequality, we're going to wrap a parenthesis around that one like that.